Hello friends, welcome to my channel. Let's have a look at problem 2501, longest square string in an array. In this video, we're going to share again a solution based on dictionary and check method or technique. First, I'll read through the problem statement to digest the task, and then we do the analysis, and finally we share the shortcode. First, let's look at the problem statement. We are given an integer array called nums. A subsequence of nums is called a square string if the following two conditions hold. First, the length of the subsequence is at least 2, and after sorting the subsequence, each element except the first element is the square of the previous number. So we are required to return the length of the longest square string in nums, or return -1 if there's no square string. So here, a subsequence is an array that can be derived from another array by deleting some or no elements without changing the order of the remaining elements. So this is the definition of a subsequence. However, from the second bullet item of the square string, so the element order is not essential. So this is a point to be noticed. Secondly, we need to notice that the length of such sequence should be at least 2. So with that said, let's look at the examples. So in example 1, so the output is 3. So we can have 2, 4, and 8, right? So in example 2, so we return -1. So you can check. So this number list is already in sorted order, right? So you can check each number and its previous one does not form a square relation. So before we look at the analysis, let's also take a look at the constraints. The first constraint is on the length of the nums list, which is bounded below by 2, right? And bounded above by 10 to the power 5. So this 2 is a consistency, right? Because the square string is at least 2 in length. So secondly, the elements in nums is bounded below by 2 and bounded above by 10 to the power 5. So in particular, it's not negative, it's positive, we'll see. So with that said, we are ready to do the analysis. So here, actually, we are going to practice the dictionary and check method again. So for this method, starting from the toSum and or from other problems alike, so we have done quite a lot of practice. For now, this technique is very standard. So the second item is on the idea. So here the idea is somewhat like dynamic programming. So in practice, we could find the longest length L of the possible square chain ending at each number y. So we store this information like the y and L, so the number and the length ending at there in a dictionary. So due to the second bullet item in the definition of square string, so as we mentioned before, the order of the elements is not important, and therefore we could sort the nums list from low to high. So this is actually a key observation for solving this problem. So the third item is on the algorithm. So here the algorithm is as below. So step 1, so we sort the nums list from low to high for us to easily check the chain. Step 2 is initialize a dictionary called aux, so initially empty, and do the following. So for each number y in the sorted list, so we check if y is a full square and the square root is in aux. If so, we are going to set the length of the square string, the possible square string, we'll say ending at y as aux y. It equals 1 plus aux square root, right? So you can interpret the meaning because the square root is the length of the possible square string ending at the square root. Then if we add the square, so the length is extended by 1. So otherwise, so we are going to set this as a start point. So the length will be 1. The step 3 is do the return. So we need to return the maximum length if it's larger than 1. Otherwise, we return -1. So for the maximal length, So actually we could use a global variable to check. So this is the algorithm. So next, let's give a walkthrough using example 1. So here is the nums original one, right? So after sort, we get 2, 3 up to 16, right? Then we do a linear scan. So when we look at number 2, we know that square 2 is not in this list, is also not an integer, right? So we get 2 is 1, so starting from here. And then we look at 3, so square root 3 is not a integer, so we store 3, 1. So the global result variable is still 1. And when we look at 4, so square 4 is a full square, and 2 is inside. So we are going to set 4 with value 1 plus 1. So the result now becomes 2. Then we look at 6. Square root 6 is not an integer, so we store this 6 with 1. So the result value, the global one, is still 2. And then we look at 8. So 8 is not a full square, so we store 8, 1. So the result values remains 2. And when we look at 16, 16 is a full square, and 4, the square root of 4 is in the dictionary, right? So we are going to use the value of 4, that is 2 plus 1, that is 16 with 3. So the global result, or the length, is 3. Because 3 is larger than 1, so we return 3. So this is the walkthrough. So with that said, I guess we are in a good position to do the coding. So the coding actually is very easy now. So first, I'm going to initialize a result variable to monitor the global length of the possible square string. And then first, I'm going to do a sort. This corresponds to step 1. And then we are going to initialize a dictionary, right? Let's call it aux. And then we do the linear scan for y in nums. So what we are going to do is to check the square root, right? So mass square root of this y. So we want to check if it's a full square, right? So we are going to take the integer part, and then we want to check if root square equals this y. If so, it means that y is a full square. And also we need to make sure root is in the dictionary. If this is the case, so we're going to set this y to be the aux root plus 1. Otherwise, so we're going to set it as a start of a square string chain. So this will be 1. So each time we finish the setting for this number y, so we're going to update this one or make a comparison. So that is aux y. So that's the full logic. So next we just need to do the return. So return result if result is greater than 1, and because the length is at least 2. Otherwise, so we return negative 1. So that's actually a full solution format for this problem. Let's do a check. Yeah, it passes the first example. Now let's look at the second example. Yeah, it passes the second example. So now let's look at generic case. Yeah, it passes all the generic cases. So with this said, I guess that's about it for this specific problem. So here the main time is consumed when we do the sort, which is an n log n algorithm, right? So here is a linear loop. So with that said, I guess that's about it for this video. You are welcome to check our channel for similar techniques and practices. So that's it. Thank you.